Okay, welcome back. Let's check the audio levels, make sure all that's connected up and good. I think we're all right here, so let me know, chap. Welcome back for another week of awesome Haskell hacking, maybe? This week we're going to continue on our journey to implement a Trek clone in Haskell using the wonderful brick library. And if this is your first time tuning in, welcome. How's it going? And this is where we're at so far. If we run our game, stack run exec Lambda Trek, we got so far as to implement the widget that displays the current sector that the player is playing in. Currently very tightly packed together, but we can work this up. We've got some commands implemented in a manner of speaking. They're just not hooked up to the state stuff. We're not updating state yet with those commands, but that's what we're going to do this week. My goal is to get this ship moving around the sector, and then we'll see how far we get from there, because we also want to add other things in the sector. So maybe we'll start adding other game objects that we can interact with. And we've got to show some state on the right here about the ship and the current sector and the enemies and things like that. Yeah, so we're getting there. Well, let's continue on, shall we? Okay, so first things first, let's open up our project. Let's go to the game. Lambda Trek command. These are our commands so far. We're going to have quite a few more, but we have engine move and jump move. In order to get our ship moving around, we have to update our state. So we have game state command input, the game state command that was parsed, the sector, and the ship. Have your green juice, stay healthy. And so we're going to implement the move command, which affects the ship and the game state. So how are we going to do that? So over in app, and a Lambda event. Once the user presses enter, right, we get the form state, the input of the text box. We run our command parser on line 34 here, and then we modify the form state by entering the game command here, and then resetting the form input back to nothing. I think basically here is a good place to dispatch to some kind of thing that's going to update the game state and provide a new one. So the function that goes to modify the forms, the game state itself. So there's some parts of the state that we're updating here to do with the form input, but the rest we want to pass off to a function that updates the game state as well. So I think what we're going to do here is we're going to do those two things. I think I can do it with the do block here. Modify takes a function. And our whole here is form game state area name, the form game state area name. update form state comes from the library, I think. Yeah, so I guess that's update form state probably has to have that shape. So, how can we do this? We can either do this. We can update the game state from the just parsed command before handing this S to update form state, or we can do it manually in a couple of steps. Alright, we can have... we start composing these together. This hole, if we put it here, would be game state to game state. And the input game state will have our command set, if there was one, and some other things that the rest of the game doesn't really care about all that much. That seems pretty reasonable. We'll call it update simulation. We just haven't implemented it yet. So we'll import it from Lambda track.simulation. We'll create a top-level module for. And we'll export from here, where update simulation function, which goes from game state to game state. We'll just make it an ID for now, so it doesn't do anything really. We need to import the types for the game state. Lambda track.state. And there we go. Let's kick off our builder and get this building in the background while we work. Fast and watch. All right. So there's our update simulation function that doesn't do anything. We compile, so everything should be just working as it was before, and now we can start implementing our game logic. So we could probably actually just start writing some test cases for movement. All right? Why don't we try that approach? So, like, there's our sector map stuff. I want to put it... yeah, a new describe block. We're going to say... Lambda track simulation. I'm gonna make this a top level one. It makes more sense. Put these inside there. Yeah. Okay. And then we'll have another describe block here for our sort of top level stuff. And it's going to be Now, updating a simulation, we want to be able to handle the different commands. Maybe there isn't really anything terribly interesting to say about update simulation at this point, because it's kind of a big leap to go from game state to game state. And really all update simulation is going to do is dispatch to a function based on the appropriate command. And that function that it dispatches to is going to handle updating the state according to what the command is. How we want the state to be changed. So all we can say about update simulation here is that if there is no command to dispatch to, it does nothing. We get the same state back. And otherwise, that's about it, actually. So our movement, the function we dispatch to our movement is going to be the more interesting one. It is basically the ID function when there is no command. And it's not even a terribly interesting one, but we'll just add it. Do we have an empty game state? I almost feel like this one's, you know... I don't think we have an empty game state, so... Can we initialize? I think our app takes care of that, actually. Nope. Oh, our top level module takes care of that. Yeah, we do have an initial state. Is muck form game state da 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 da. Okay, so let us make a constructor function for initializing this initial game state, and then muck form will be just the wrapping around that. That'll just make writing this test a little bit easier. So. In fact, we don't even need to bind anything. We just write initial game state. And if the spec of initial game state changes, we'll have to update this test. But it'll hold that passing this to update simulation could be initial game state. Something like that. Okay, so let's open up state. Let's derive that function. For now, just a definition. Takes no arguments. And game state command can be nothing. We're going to need a sector and a ship. For now, our initializing function that we do have in Lambda Trek just uses the empty sector and a ship. So let's use that and a predefined ship of 2-2. But I think we'll ultimately want a function to take those as parameters. We're going to need overloaded strings here. Don't need the parentheses here. Okay, that's good. Then run. Buck form can just take initial game state. Get rid of those. And make sure my builder is actually building. Sometimes it gets a little, the IO, file IO gets a little behind. Okay, we're good. And what do we got so far? We don't need that yet. That's good. Okay, we're mixing up a couple of things here. So I think we can stage this one and this one. Yeah, we'll do that. We'll add initial state. Definition. And so app now is going to have that. We have this new module that we're going to use. We're going to stage all of this once we're done. That. Not make tests, sorry, static test, fast. Okay, so we gotta import those. We need state. And get is not in here somewhere. Let's see, Lambda Trek. Simulation vector. We called it get tile, I think. What am I? Empty sector. Empty sector tiles. Okay, there we go. Okay, cool. All right, so now that we have that, let's go back to our spec. So we don't need to update, we can get more fine grained now. Let's describe handle move command. Should move the ship to an empty space. And so if we give this update simulation, no, sorry, handle move command function, hypothetically, we want a slightly different state than the initial game state. State with valid move command. So we want that to be the initial state such that the game state command is just move engine move, and let's say for our test case we're going to move 10 to 10. Okay, we've got a couple holes and stuff I've got to finish filling in here, so we should give this state with valid move command. And then we need an expected state. Right, and this will go here, it should be expected state. And I think, so here's what I'm thinking here for the valid move command thing. When I'm writing handle move command, I just want to pattern match on the command that's available in the game state. Or actually, handle move command. I almost don't. It needs to take the whole state anyway. But I don't want handle move command to have to like pattern match on the maybe field of like which command it actually is getting, you know what I mean? Because handle move command is gonna like have to look in here to get engine move 1010. I guess when we dispatch to it from update simulation, we can just assume that this is here, otherwise we wouldn't be called. Yeah. I don't know, maybe I'm getting too fine-grained here. We're not fine-grained enough. I don't know. Anyway. Because the reason why I bring this up is because do I want to write in every handle function that the game state command should be set back to nothing after it's been handled? Or should update simulation handle all that part of the state bookkeeping, so that handle move command can just do the move code, and we don't have to repeat ourselves constantly with game state command equals nothing. Because ultimately, once we handle the command, we do want that to be the end state of the game loop. For command this to go back to nothing. So already this API is feeling a little bit meh. So maybe we can do this at the, we can write this test at the update simulation level. Instead of calling handle move command directly, we'll make this context. So what I like to think of context blocks as given some state or context, these things should happen. Right, it's I don't know if you've ever seen a way of kind of writing lightweight behavior-driven kind of specs, sort of, as this idea of like given when then as the mnemonic. So like given some context, when this action happens, then this end result is the end result. Context I find is good for describing the given part. So given the engine move command, the context of the engine move command, or given the engine move command, it should move the ship to a valid engine move command. So given a valid engine move command, it should move the ship to an empty space. Or to the empty space given by the command. That sounds right. So instead of writing handle move command, I'll just write this as update simulation. Update with valid move command. And then we can just care about the final expected state, the game state command. We could even write this separately, that this game state command resetting happens for any given handled command. Like whenever we handle a command, the final state should be this. I'm just gonna write it this way for now, and then I'll try and extract that. So then we look at the ship. And that ship should be 10-10. So we don't have any of these in scope, so let's bring those in scope. And Lambda trick. And ship. Some simulation. what are we missing? Initial state. What did I call it? Init state? Initial game state. Okay, and that'll go. Oh, it didn't. Okay, what did we do? Right, we haven't implemented anything yet. Perfect. Alright, we didn't clear out the command either. So let's go implement this and make it work. Simulation, barrel. Okay, so game state. Let's case match, pattern match on the game state. Command. Right, and if we have just move command or engine move, we do something. Anything else for now, we'll just return game state as is. So we don't have that in scope, so let's bring that in. Lambda correct command. Alright, some holes, lens. Okay, and what did I do? Lens not micro is the library we're using. Okay. That's why. For some reason, I thought I was using the full lens library. That's ultimate might. And then we need the game state in order to get that. Oh, this should be here. What am I missing? Is that the right field? Oh, that should be it. Oh, it should be. Oh, okay. It's... That's... okay. My bad. I didn't realize the generated names would include the prefix. The main lens library usually does, like, some prefix thingies. Maybe we don't need that. Okay. So this type tool here is what we need to handle, and for engine move, we got to check a couple of things and blah 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 blah. So we're gonna hand this off to we're We're gonna hand off to handle engine move. So handling the engine move, we're gonna need to give it the... we can either pass it the full command, like this, ignoring the X and Y. We just care that we're pattern matching it, that its engine move. In which case, if we ran, the next one would be like that. We could also, maybe, if you have a command, just dispatch to handle command. And let us do the pattern matching there. And then we'll do the cleanup action here. We can set the
everyone has had too much of now. From mega cities like Central to the vast nobody wants more of it. How it used to
game state command
exactly that.
back to nothing.
Remember treasures of the forgotten past.
Oh, no, it's not the right one. No, this is like this. That's good. So that's some lens funkiness. If you haven't seen it before, these are the two main patterns I use lenses for. Is this operator here, which is like view. It's almost like your dot operator in a lot of other languages. If you're trying to like view a struct or some kind of structure. And then the setter. So like the main idea was originally like getters and functional getters and setters, whatever that means. It's a whole lot more than that, and it's like pretty cool the things that they were able to open up just by exploring this path. But the other one here is just update. So on the left side of this and thing, we have the thing we want to update, which is like going to be a game state that this function returns. Then the lens into that thing, the place where we want to update, and then the value on the right-hand side of this little percent squiggly that we want to set that to. That's, if you can just hold that in memory, that's pretty much like 99% of the uses I use lenses for. The other 1% being traversals and prisms and stuff, which is very, very useful as well, but no, I don't use them quite as often. Maybe like 95%. They are, prisms and traversals are pretty useful, but I think for me at least, that's where the cliff in, or if you want to think of it as a cliff, or like the hockey curve of complexity of using the lens library laid a little bit after using these first couple of operators. It goes up from there. It gives you a lot of cool stuff because these setters can be deeply nested. And they could also be passed around, which makes for, as we've seen with some of these UI libraries that use them, really handy when you have a deeply nested tree of things like UI elements, and you want to give your users an easy way to reach deep into that tree to update little parameters and settings and things like that.
Everyone has had too much of now.
So let's implement handle command.
Like Central to the vast and desolate outlands. Nobody wants more of it. How it used to feel is what the people want. And rememory offers us exactly that.
I think we called it command or game command.
Remembered treasures of the forgotten past.
Should probably pass the game state in there. And return to game state. That's just command. Yeah.
Retros. Remembered treasures of the forgotten past.
Okay, cool. This will be a little nicer. so we can back and flip these arguments. This will be a little nicer too. Even nicer still. Because then we can lambda case on the command. And then we can do engine move. And then we can do jump move. We need to add lambda case. Language lambda case. Okay, one argument leader there. Right now, we're not implementing jump move. Okay, cool. Okay, so engine move now. We just have to move the ship. First, in order to move the ship, we have to look at the... Well, we can look at the... The tile map isn't going to be the best place at the moment. It's going to work well enough for now to make this test pass, but when we get to collision detection, it's not going to work. So let's just make it move there. And then we'll figure out the rest as we go. So engine move XY means that we can just change the ship to have its position XY. So we could probably even just use that. Game state. Game state ship. And we can change the game state ship to be a new ship at X and Y. So we're going to import that. Couldn't match. Oh, what was our ship constructor takes? Yeah, ship X, ship Y. That could be fun. Oh. Right, sorry. I'm using the wrong lens here. It wants a type there that's maybe command to maybe command. A function. Oh, what's the right thing for that? If I just make this cause nothing for now, just make that go away. That's kind of weird. Should figure out what the right operator is. Maybe that's just a lens.micro thing. Let's check that out just to make sure that I understand that. Setters. Over, okay. So percent squiggly is over, which applies a function over the thing you're setting, you're focused on. Okay. We want a sign. It's the same thing as over with const. There we go, that's what we want, dot squiggly. Meh. My bad. We get rid of that, and then we're good. Sweet. Okay. So then all our tests passed there. And now we should have basic movement going. Not the full movement that we want, but we should be able to move 2 to 2. We're already there, so let's try something more interesting. 10, 10. Right, move 3 to 3. Move 8, 8. All right. So we got ship movement going, which is great. Now I have to type this in all caps. It would be great if it was just already capitalized. Or the parsing didn't care. Okay, so we can move around the map. We could probably move... Can we move -10, -10? No, we can't. 100, 100. Way out of range. So we have a problem right there. But basic movement going, which is great. Okay, so now we have a couple of challenges. One, our command validation. Right, when we get an engine move command anywhere in our program, after we've parsed it, we should know that that is a valid move, at least as far as the parameters that have been parsed are concerned. So none of the values in the command are wrong. And wrong in this case is going to be anything outside the bounds of a sector. Right? We know what the bounds of the sector are for our game design, at least. And values outside of that range shouldn't even parse. It should just be a parse error. So that when we implement the engine move handling function here, we don't have to think about... excuse me. Is this an error case we don't have to validate that the input is right. We don't have to check that X is within bounds and Y is within bounds here. Alright, that would get kind of annoying to have to like do that over and over again, especially as your program grows in scale and scope. So it's just nice to be defensive. When you have a parser, use it to validate your input. So we could fix that. Let's go ahead and commit what we have so far, though, even though it's not fully working the way we want it to. So this change adds a handler for the engine move command, which we just call move. It doesn't, not complete. Doesn't check for collisions, game objects, etc. Okay, so let's tackle the parsing problem. And then the other one will be, once we add game objects, we can talk about collisions and how to handle those. So let's make the parsing of the command an error. Okay, so engine move. Here we parse that x is a digit and y is a digit. We should also, before constructing our engine move command, validate that x and y are appropriate digits. We know what digits are valid for an engine move command because, like, our design is such that the sector size is going to be fixed by our simulation. I think we're going to go with, yeah, like 15 by 15, roughly. In fact, we should probably document this as part of... Right, so x should be... And the indices in our simulation are 0... 0 to 14. In fact, it's in our spec here. Yeah, 0 to 14. All right, it's even specified by our test suite here, so let's make sure that those are appropriate values before returning the engine move. So see, we can early exit here. I wonder if we can use when. I wonder if we could use when here to do kind of like the return value of when is unit. I'm going to write fail here, invalid y. So when x is less than 0, or x is greater than 14. When comes from control.monad. We'll add that here. Okay, and let's just add a couple of tests to make sure that that works the way we expect it to and parses what we want. So we're going to use our run command parser. And move to 2 should be valid. We have to, of course, import that. Oh, this might just be precedence. There we go. And should not parse invalid move. We do move 100, 100. That should be nothing. Right. Because run command parser just does just to maybe with that thing doesn't return any more useful information about why the command failed. Which we might want to change, actually. Because now that this works, the API for this is that the command is wrong. And from a user perspective, that's not going to be terribly interesting. If I try to implement move 100, 100, and all we could say about it in the nothing case is that the command didn't work, that would be a pretty frustrating user experience, right? I'd be like, why? What did I do wrong? And we don't want that for our users. Right? We want our users to know what they did wrong so they can fix it. Because it's a command input interface. And it's text-based, and that's the communication channel that we have with them. So, and we can't figure that out from just nothing. So we need more information there, basically. So this is an okay first pass, but I want to change the spec to be different here. So let's commit this, and then we'll fix the parser to be more descriptive in the failure case. Right, update move parser. We do not parse invalid move commands whose X and Y parameters are out of bounds of sectors. Okay, so the next step to improving this situation is to add some error reporting. So we basically want to change the type of run command parser to be either command parse error or command. Now, how can we do this with the text.parser parameters.readp? I think we're gonna have to figure out. We can define our error type. The first one we're going to be interested in, of course, is the invalid move command. And maybe text. I'm going to have two things, invalid X and invalid Y. Okay, so we'll import data.text. At least the type for now. Okay, so then list of maybe becomes the problem here. So we have a list of these tuples of command and string when we go to parse command, run the command parser. Let's boot up our parser module into a REPL and just play with this a little bit, see what we get again. So parse command. So the function we're using is read p to s with parse command as our parser, and our input we move 100, 100. Save that for a second. We got to add text parser combinators .read p. Let me import that directly. Oh, parse command isn't in the scope. That's funny. Oops, there we go. Okay. Well, let's get rid of that pipe pull for a second. Okay. This is the reason why we don't get an error. Read P2S is empty. So we can't get that error back from that. So we're going to have to figure this out a little bit. Error text. Maybe we might have to import a parsing library that can do this, but let's see if we can get away with it. Yeah, so this basically means that any parser that fails is always going to be the empty list. So this pfail always fails. It's the parser that just fails. That's all it does. It's always empty list. So this library isn't going to be good enough if we want better error messages. Otherwise, maybe the way we can do it with this library is if I read P, all our read P's return either's themselves. We'd have to have a combinator here that's a little bit different than list of maybe in order to recover this. Well, one thing we could try for importing another library would be to make this return either with our command parse error, or our command. And that would do that, and then this would be here dot left. Invalid move command, engine move. This might be just an overloaded strings problem. Oh, that's... not happy with that. Right. When is it going to cut it here? How to write this without getting too much indentation with nested ifs. And this is going to type check. Oh, because we got to also change here parse move to have the same type as parse jump move. And command. And this whole thing is going to be command parse error command. The return type of this, and then this is where we get the type error that we're expecting with list of maybe. parse result is going to be our list of tuples, so either command parse error, command string, and we're going to return either command parse error, command. That's the empty list. We're going to return left, no command. And otherwise, we have some command, some result. And we just want to return result. With no command, put some equal show on that. Oh, we didn't get quite right. What did I want the type to be? No. It's not it. Oh, maybe we just don't need FMF first. I'll have to do it anymore. That's probably it. Yeah, okay, there we go. And then here, oh, okay, we're gonna get some helpful suggestions. We don't need parentheses here. Oh, yeah. Yeah. Is there a nicer way of doing this? I feel like there ought to be. Something like when, but it returns not unit. So we want something that takes the when, something similar to the type. Yeah, a bool. Yeah, so when has this type? Because we'd have to pass in something for A. Right? Couldn't write applicative F. Bool. FA, FA. Well, X monad has one, like when tick, but it's monad instead of applicative. I wonder if we could do something like that ourselves. Let's try it. See if we can make a function that actually works this way. Bool FA FA, and then maybe it'll become obvious why it can't be done, or why it doesn't exist in control.monad. When predicate and F. Oh, I see why now. It just doesn't make sense. So we'd have to produce an A in either case, so like this Boolean doesn't even matter. It's not the worst. If there's a way to make that a little nicer, that would be good. We could actually reduce the number of ifs by doing the one Boolean expression. And then we could use, maybe we could use alternative. So, if this is true, and this is true, or we just can't say which X or Y. We could say invalid move, X or Y, or X and Y must be greater than 0, must be between 0 and 14. Not between, but from 0 to 14. That's about right. Okay, so that module is fixed, but obviously the code that uses the parser now has to be updated. So let's go do that. The parser is used in the UI. No, not UI, that's just rendering. App. Here. It's no longer a maybe command, it's an either command. Maybe we can run this, we can update this to be like case, we can case match on this. Left, command error. Otherwise, we have a command. So in the command error case, we can modify form state just as we would update simulation s. And then maybe we have a new field, game state command error. Command error and game state command. Just to be super sure, I'll just make you set that to nothing as well. So then let's add that to the state. We'll add it here. Game state command error. Maybe command error. I don't know if we want to expose the command parse errors directly. It might just be nicer to have this as rendered all the way to text, if it's going to be set at all. Or else we can make it the type and then have a render function in our UI that can translate it to text. Either way, yeah, I think maybe the type here will be nice. Let's do it text. We have the parse error here. We'll set this to just render command parse error. And let's do it here, save ourselves a character. It's over to the left a little bit. Okay, we don't have a render command parse error function, so we're going to need that. command parser errors down here. Render and parse error. And this will be command parse error to text. That'll just be message. Yeah, so our tests are breaking, which is good. Okay, so then we'll get our API back in shape. And get our tests updated. So now we no longer get this. So if it's a valid one, we should get right engine move. And in this case, we should get left invalid engine move. And the string should be something else. So an overloaded strings thing. Good. Just copy that. Okay. And then our other errors. Game state command error. Because initial game state does define it. So let's go do that. Oh, fat fingered by accident. You gotcha. Okay, we're back to passing, which is good. Okay, so that's how we're going to handle parse errors. Done. And that's working. So now we know that when we get an engine move command, it's going to be valid. And we can't get a bad one. So if we check out our game now, if I try to move 100, 100, I don't think I'll get the array access error anymore. I'll get an invalid command thing, and it just won't do anything. So the next part of this is to actually display that error to the user and make sure that the command palette gets cleared out, actually. So let's... I'm not quite done this yet. Almost done, I would say. So render command parse error isn't in there. Let's re-export that. From our top level module here. Oops, I might have broken things because of circular imports. Yeah, never mind. We're not going to do that. Well, parse should be exported from here. Maybe my Haskell process is out of date here. Anyhoozle, so yeah, the game state command error here is fine when we set that command palette to nothing, and oh, the command input needs to game state command input equals blah. And we'll just be super sure. Error, nothing here. Okay, so it clears it out. It sets the error. We're just not rendering it yet. So let's commit this where we are at and add a space in our UI for these command errors.
Susan left some bite marks in the bedspread. Yeah, I was trapped in a nightmare eating French bread. Yeah, was it toast? Annabelle, dry my creamy tears in our bed.
Okay, so let's go to the UI code. Let's just take a gander at it. So we could put... I'd like to keep it close to where you input the command. Or else maybe this is kind of like the biggest area and where most of the game is going to be... Gameplay is going to be focused. So if there's a place where we could flash that error, if it's present, display it, that would be pretty good. Or we could display it right above the command palette, maybe. I wonder if there's a way we could color the text too. That would be nice. I think what we can do is if we get the game state out of the command palette, we could check if the state of the error. And if it's set, now we can display one thing or nothing. Maybe that was what we could do. So we can maybe try command error. If there's a null widget type that just doesn't display, this would be super nice. Search the brick library. Let's see, widgets. The empty widget. Sweet. Okay, so the command error widget. Is going to be equal to game state command error of the form state of f. In fact, we could do this. I want to do this lensily. Command error. If it's nothing, we do the empty widget. Otherwise, it has a message for us. It's already rendered. And we just need text, which is stir message. Import micro.lens. Or lens.micro, sorry. Stir wants to be a string, so we have to pack this text. Okay, so let's import data.text. We have that qualified text. Okay. And then we just have to use command error widget vertically with render form. Oh, this is so cool. I love it. Including an empty widget was a great idea. It's a small idea, but it's a nice idea. Super. Doesn't wrap. That would be nice if it wrapped. That worked though. It wrapped, and then we can color it. That would be super dope. Oh, there's a text widget. Okay, then we don't need to pack the string ourselves. Build a widget from text value, breaks new lines up, and space pads short lines out to the length of the longest line. The input string must not contain tab characters. Okay, that's not a problem for us. Text wrap. Sweet. Ah, sweet. TXT wrap is what we want. Ah, dude. Even better. Nice. Ah. Sweet. Yeah, that's pretty good. Pretty good. Yes, we don't have to pattern match here. That's fine. Let's do this refactoring. Oh, we got precedence issues. Oh, that'll be fine. Okay. That tightens that up. That's good. I like it. And what else can we do? And then attributes, I guess, is where we can do color and stuff. Okay, okay. So we have attribute map. Okay. Okay, so render 2 is what actually passes the attribute map. How does this attribute map getting passed around? Oh, this is set in the app. Okay, okay. Gotcha. Okay, so this is good enough. Let's commit that, and then we'll maybe just try to fluff it up a little, highlighting there, and then we'll wrap up the evening there. Okay, so add a command error box to command palette. When the error command error is set, we render the error widget as text, otherwise empty. Okay, and then in our app, when we set it up, we have an app attribute map. Okay. Lambda attribute map. Gotcha. Just the default attributes. And okay, so our attribute map can be something like this. Okay, so let's add to this a tuple. And we'll do highlight error, the FG red. Okay, those names aren't imported. Oh, because they want v.red, okay. I have v.red. No, FG comes from something else. Brick.util. So it's doing an is instance, or is string instance here. So these, I guess these have to be fixed to something. So adder name. Okay, maybe I just have to put adder name on it. Okay, that should do it, right? Yeah. Good. And then we can go into our UI. The use our attributes. With adder. So here with adder, highlight, error, text drop. This is not working at all. Compose. That's probably why. That's gonna bug me. I'm going to keep wrapping these strings in adder name. Cool. So let's see if that worked. Yeah. Sweet. That case is kind of weird. But, okay. I'm gonna commit that. Add error highlighting attribute. This lets you render the command error text in red. Super. That's some pretty good progress. Not too bad. We got the ship moving, which is what we wanted. We improved the parser handling situation so that errors with command input are highlighted to the user, or can be. We implemented that at least for move so far, and we can implement it for others as we go along, which will be great. And then, what else? Yeah, that's what we got so far. So we're moving along in the game. Then I guess next week we will probably move on to adding some game objects to our sector to make it more interesting to interact with. And so we'll have to do that and handle collision detection so that other kinds of errors we can also display here. Which is probably a good idea that we did it with maybe text in the game state so that... Well, no, command errors should just be command errors there. So I think if we want game affecting errors, maybe we want to display them somewhere else. But we're going to figure that out next week when we get to it. So if this is your first time tuning in and you haven't followed me before and you're just curious, welcome. Thanks for watching. I usually do these streams once a week on Tuesday evenings at about 10 after 8 in the evening in the Eastern Standard Time Zone. So you can follow my schedule there. It's also my profile page, and if you just want to like subscribe or follow along or whatever the heck the button is here on Twitch, click that button and then you'll get notified when I go online. And if you're in a different time zone, you're watching on my YouTube stream, on my YouTube channel there, you know what to do there, hopefully. So just subscribe, like, and all that stuff really helps. Leave a nice comment. I like hearing from you. Of course, there's also the Discord channel for this stream, which you can find by going to the handy dandy link above my floating head. And if you go there, you will be able to find our channel and talk to me between streams about your projects, what you saw on the stream here. If you're watching on YouTube and you want to ask a question, feel free. And yeah, let's chat about Haskell and have happy fun times there as well. So all of the code that I'm about to push up is available on GitHub, which is where we put the code for pretty much all of the projects that you see on the stream here. I'm Agent Ultra. My GitHub is Agent Ultra. It's me. This is Lambda Trek. So, yeah. That's what we got. My socials. I'm also on Mastodon in the Fediverse, so you can follow me there. I'm on the types.pl server. My name there is also Agent Ultra. It's been a slice. May your monads always be free and your types always check. And we'll see you next week. Take care.